Hello, we are back with another laptop repair. So this is a motherboard of an HP laptop. So this motherboard is having a problem on the backlight. So if you plug in a display, we will get a picture on the display, but there won't be a backlight on the display. So this motherboard we received from another repair shop. So they have already tried to replace another display, but it is still the same problem. In this type of case, we need to find the circuit that is responsible for providing the voltage that is necessary for the backlight of the display. Okay, now we are looking at the schematics of this motherboard. This is the LCD connector. We have 30 pins totally in this connector, and display cables connected on this pin, and all the voltages and signal will go through this way to the display. So we have some voltages that need to be checked in these connectors here. So the main voltage for the backlight is VBAT, which comes from the current sense resistor, which is the common point. So when there's only the adapter, we can see 19 volt. When there's only the battery, we can see 12 volt approximately. But when there's both source of power, only we can see 19 volt. Okay, so mostly the voltage on this side will be fine because the board is turning on. So if there is no voltage on this side, the board will not turn on. So we need to check this coil here whether it's okay. So if there is a short in this coil, or if there is no coil in this place, so there won't be voltages on this side. So we need to check this point. And also we need to check pin number 1 and 2, which is the supply voltage for the LCD circuit, the LCD VCC, and this voltage is supplied from this circuit here. So this small P channel MOSFET, it switches the 3.3 volt run power back to this here. So this voltage goes straight away to the connector. So we need to check these two voltages mostly for the backlight problem. Okay, here's the display connector. So pin number 1 is starting from this side. So we need to check 3.3 volt at pin number 1 and 2, and also we need to check 19 volt at pin number 29 and 30. So let me plug in the adapter now. Let us check it. Okay, on this point, okay, we don't have any voltage right now, so I'll turn on the board so that I can see the voltage. Okay, the board turned on. So we are not getting any voltage on this pin here, on pin number 30. Yes, we are not getting any voltage on that pin either. So we need to check those circuits that is responsible for providing these voltages. So on pin number 30, there's only a coil, but on pin number 1 and 2, the 3.3 volt is supplied from a P channel MOSFET that is switching the 3.3 volt run power as LCD VCC. So we need to check that MOSFET. Okay, so what is the name of the MOSFET? It's QB2. So let me zoom a little to find the MOSFET. QB2. Okay, it's written at this point here. You can see it's QB2. So somewhere here. I think this is QB2. What about this one here? We have a capacitor below that. Yes, so CB21. So it's a capacitor. So I think this one, yeah, it's this one. This is the QB2. So you can see the lines. So it's coming out here. So this is the drain, and this is the source, and this is the gate point. So we need to get a low voltage on the gate with respect to source. So then the voltage from the source will be supplied to the drain point. So it goes to this place here and goes back to this pin. So you can see the line. Yes, it's visible. On the gate pin, I'll turn on the board. Yes, we do have 3.2 volt on the gate pin. So 3.2 volt on the gate pin will not turn on the board. I mean, will not switch the 3.3 volt from source to drain, because as it is a P-channel MOSFET, we should get a lower voltage. So we are getting 3.3 volt on the gate, and on the source also we are getting 3.3 volt. So the MOSFET is turned off and there won't be any voltage switching to the drain side. So we need to find QB3A, which is also an N-channel MOSFET, which is controlling this MOSFET here. So you can see this is the QB3A. So we have to check on pin number 1. Okay, it's not pin number 1. It's like yes, on pin number 2, or else it should be on pin number 1, 2, 3, 4, 5, 5. So on pin number 2 or on pin number 5, we need to check there should be at least 3 volt. Yes, we are getting 3 volt on that pin. Okay, on the other side, so it's an N-channel dual MOSFET. No, we are not getting any voltage on the other side. We have a problem. Both voltages are not present on the display. That is the 19 volt and 3.3 volt is not present on the display. So let's hold on for this section here on the 3.3 volt. Let's find the 19 volt. So we can see only the coil between the current sense resistor and back to this point here. So let's check the coil where it is. So there's no problem here. What is this one? So it looks like someone has tried to repair something before. Okay, it's like it was a diode on this place. They have used a 0 ohm resistor. Okay, let me leave it a bit. Oh, if you look here, something is missing here, and it looks like a coil. You can see it looks like a spring, the notification. So it looks like a coil. So let me check the voltage on that side. So on both sides. So I should see 19 volt on this side. Yes, we are getting 19 volt on this side. On the other side, we are not getting any voltage. So this is the coil that switches the 19 volt from the current sense resistor to the LCD circuit here. So it is missing. So that's why we are not getting the 19 volt at pin number 30 and pin number 29. Okay, now that looks fine. Let me place a new coil in that place so that we can get 19 volt on the display connector. Okay, so now we are looking at the LCD VCC circuit. So this is 3.3 volt. When this MOSFET switches this 3.3 volt run power on this side, so you can see the arrow is pointing outward, so it's a P channel MOSFET. So in order for the P channel MOSFET to conduct the source to drain, we need to get a voltage on the gate lesser than the source. So we are getting 3.3 volt right now at the source, so we need to get a lesser voltage than 3.3 volt. So now we are getting 3 volt on the gate, so therefore the P channel is not conducting the voltage from source to drain. So there comes the importance of this MOSFET here. So it's an N channel MOSFET. So N channel MOSFET is opposite of P channel MOSFET. So if we give a higher voltage with respect to source, it will conduct, and if we give a lesser voltage or equal voltage, it won't conduct. So as we know, the ground point is connected to the source. So if we get a 3.3 volt on this line, so the N channel MOSFET will start conducting the source and drain together, and we will be getting ground at this side. So if we are getting a ground on this side, so the voltage that is coming after this RB26 resistor, the 3.3 volt, will not come hereafter due to the low impedance at this point here. So here we will be having 3.3 volt, and here we will have 0 volt. And at this time, when the gate is at 0 volt, the P channel MOSFET will start conducting the voltage to that side. In this case, here we have that there is no voltage present at this point here. We need to check why there is no voltage at this side, which should be 3.3 volt. So mostly the signal comes directly from the PCH, from the LVDS section. So just we'll search wherever it goes. You can see, yes, it's coming from the LVDS section of the PCH. Here we have the cocoa point, which is the PCH. So we are getting low impedance or low voltage at this point. So actually, if you are getting a low impedance on this side, we can't help this circuit because it's directly inside the PCH. There's no any components between the signal up to the PCH. So we can remove this MOSFET from this place, and we can just jumper the source and the drain, which means the ground point to this point here. So we will be getting low impedance at this point, where the P channel MOSFET will be getting a low impedance and it will start switching. And also, so this MOSFET, if you remove this MOSFET from here, these are both N channel dual MOSFET, so in one package, so both of the MOSFETs will be removed. So we will getting high impedance at this point also. So we will be getting LCD VCC on the output side. So now let's remove this QB3A and just jumper the source and drain together so that we can get ground for P channel MOSFET to turn on. Right, I will just connect the adapter now. So here we have the MOSFET, the N channel dual MOSFET. So we were getting 3 volt on this side on the pin number 2, which is a gate of one MOSFET, and on the pin number 5 we are getting 0 volt, which is a gate of another MOSFET. So this is the MOSFET on this side, which switches the ground for the P channel MOSFET here. So let's check. At this point it looks like a resistor, but anyhow we saw that the signal is directly coming from the PCH. There is no components in series with this connection. So anyhow, I'll just check the impedance value at the pin number 5 of this MOSFET to see whether the PCH is sending low impedance. I'll just turn on the board so that we can see that. Okay. Yes, we are getting 37 ohms. So if we are getting 37 ohms for an N-channel MOSFET, it will not conduct. So we need to remove this MOSFET and connect the source, I mean the ground and the drain point of this MOSFET, so that we will be getting ground for this MOSFET here. So unless we do this type of work, we can't solve this problem in this motherboard, because there's a problem inside the PCH which is unsolvable. So this is a tricky way. Okay, let me check with the continuity where the gate pin of this MOSFET is connected with this MOSFET. So let me turn to continuity port so you can hear the beep. So this is the gate of this MOSFET, P channel MOSFET. Most probably it's on this side or this side. Wait a second. Okay, actually, according to the schematics, there is a resistor in series from this MOSFET, from this MOSFET to the gate of the P channel MOSFET. So there's a resistor in between this. That's why we are not getting a beep from that. So there's a 68 kilo ohm resistor. Okay, so one thing I can do. So if I just remove that resistor from there, so I will be getting 0 volt for the gate of the P channel MOSFET. Alright. So we need to find that resistor. Okay, let's check from the continuity. This one, no. Yes, this is connected to this pin here, and the output of this resistor is connected to where? Yes, it's connected to this pin here. So the ground point is at this side, I guess. Yes. So when you look at this point here, this is the resistor that is in series from the gate pin to the N channel MOSFET here. So if we remove this MOSFET, the resistor from this place, we will be not getting 3.3 volt for the gate of this MOSFET. So the MOSFET will switch 3.3 volt back to this side. So we have another problem. If you look here, still this MOSFET is turned on because we are getting 3.3 volt at this point here. So as an N-channel MOSFET, it will turn on and will conduct the low impedance at this point. So this resistor is just a 62 ohms. So it will surely conduct the low ohm at this point. So our LCD VCC will not be generated. So in order to solve this problem, rather than removing this MOSFET, we can remove this resistor. We can remove this resistor from this place. So we will be getting 0 volt on this gate and also on this gate here. Okay, now we need to find RB26 resistor. So you can see it is written as RB26. So it's top to bottom. So look, it's on pointing from bottom to upwards. So maybe this one, this is the RB26 resistor. So we'll just remove this one and check whether we are getting the LCD VCC voltage on this side. Okay, the adapter is connected. Let me check on the output of this MOSFET. Oh, still we are not getting voltage. Wait a second. We are not getting any voltage on either sides. Oh, now I have to turn on the board. I forgot it. Because it's a run power. So only if we turn on the voltage, we will be getting 3.3 volt. Wait for a second. I'll just connect the power button here. Okay, now let me turn on the board. And the board has turned on. Now let me check at this point. At this point. No, still we are not getting any voltage. So on the source side, we are getting, on the source side we are getting 3.3 volt, but on the drain side we are not we are getting 3.3 volt. Okay. So on both sides now we have 3.3 volt. So that is fine. So on the gate side there is 0 volt because we have removed that that resistor in this place here. So there's a 3.3 volt, and on this side we don't have any voltage. Okay. So Now let me turn off the board and connect the display and see whether we are getting the backlight. So there were two problems. So there was a short in the inductor. Sorry, the inductor was missing. So we replaced an inductor, and the LCD VCC, there was a problem in this circuit because of the PCH that is sending low impedance to this circuit here. So that's why we are not getting LCD VCC. So just we have bypassed that circuit in order to get 3.3 volt at the LCD connector here in order to supply the LCD circuit inside the display. Okay, I'll just take the display now. Let me connect it and try again. Okay, now it's connected. Always try to remove the adapter before connecting the display, because the display pins are so small. The width of the pins between each pins are so small, so if you plug in a slant manner, so it will show other pins. So it's better to always disconnect the adapter before connecting the display. Right, let's go for a test. Yes, we got the display and the backlight is now visible. You can see it's working now. Okay, so we solved the problem. So thanks for watching and stay tuned for future updates. Bye for now.